Good morning everyone. This is E. Chandrasekhar, Assistant Professor of Mathematics, Department of FME, St. Martin's Engineering College. Today I am going to explain about mean value theorem in calculus. The mean value theorem is one of the most useful content in differential and integral calculus. The mean value theorem is also known as Lagrange's mean value theorem. The mean value theorem is abbreviated as MVT. So let us start our Lagrange's mean value theorem. Basic three mean value theorems will be there. First one is Lagrange's mean value theorem. Second one is Rolle's mean value theorem. The third one is Cauchy's mean value theorem and their applications. Let us go for Lagrange's mean value theorem. Statement states that Lagrange's mean value theorem Lagrange's mean value theorem statement says that let f of x be any function such that first condition f of x is continuous in closed interval a comma b. The second condition, if f of x is differentiable in open interval a comma b, then there exists at least one point at least one point c in open interval a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. Then there exists at least one point c lies between a and b, then such that f dash c is equal to f of b minus f of a by b minus a. So to prove this theorem, we define a function g of x is in closed interval a comma b. We define a function g of x in closed interval a comma b by g of x is equal to f of x plus ax. This is, take it as equation number 1, where capital A is to be determined, constant to be determined, where capital A is constant to be determined. So such that g of a is equal to g of b. That is, g of a is equal to f of a plus aa. Similarly, g of b is equal to f of b ab. So equating these two equations, g of a is equal to, since g of a is equal to g of b, therefore f of a plus aa is equal to f of b plus ab. That is a into a minus b, which is equal to f of b minus f of a. That is, a can be written as f of b minus f of a by a minus b. This, take it as equation number 2. With this value we substitute a in equation number 1, we get with this value of a we substituted Since the function g of x is continuous in closed interval a comma b and g of x is differentiable in open interval a comma b and g of a is equal to g of b, then g of x, the function g of x is satisfying all the three assumptions of Rolle's mean value theorem. So g of x, since g of x is continuous in closed interval a comma b, similarly g of x is differentiable in open interval a comma b and g of a is equal to g of b. So according to Rolle's theorem, let f of x be any function. F of x is continuous in closed interval a comma b and f of x is differentiable in open interval a comma b and f of a is equal to f of b, then the function f of f, then there exists at least one point c in open interval a comma b such that f dash of c is equal to 0. According to Rolle's theorem, here the function g of x is satisfying all the three main assumptions of Rolle's mean value theorem. So g of x is satisfies all the three assumptions of Rolle's mean value theorem. Rolle's mean value theorem. Therefore, according to Rolle's theorem, f dash of c is equal to 0, but the function g of x is satisfying all the three assumptions. Hence, g dash of c is equal to 0. But g dash of x is equal to f dash of x plus a. So as we define the function g of x as f of x plus ax, so the derivative of g dash of x is equal to f dash of x plus a. So substitute c here, g dash of c is equal to f dash of c plus a. By putting g dash of c is equal to 0, we get f dash of c plus a is equal to 0. That is, f dash of c is equal to minus a. Take it as relation number 3. Using relation 2 in 3. Therefore, using relation 2 in 3, we obtain f dash of c is equal to minus of f of b minus f of a by a minus b. This can be written as f dash of c is equal to f of b minus f of a divided by b minus a. This completes the proof of Lagrange's mean value theorem. So according to Lagrange's theorem, there exists at least one point C lies between open interval a comma b such that f dash of c is equal to f of b minus f of a by b minus a. So we explain the Lagrange's mean value theorem geometrical view of Lagrange's mean value theorem. Lagrange's mean value theorem. Let y is equal to f of x be any curve. The two main assumptions of Lagrange's mean value theorem are of the following. The two main assumptions of Lagrange's mean value theorem, Lagrange's mean value theorem are of the following. Y equal to f of x is continuous in closed interval a comma b, continuous in closed interval a comma b. F of x is differentiable in open interval a comma b. At every point x is equal to c. At every point x is equal to c. At the point c as c comma f of c, there is a unique tangent. There is a unique tangent to the curve y is equal to f of x. There is a unique tangent to the curve y is equal to f of x. As shown in the figure, as shown in the figure, this is x axis, this is y axis, this is origin. So y equal to f of x be a curve. So let us join these 2 points, end points a comma b, a comma f of a, b comma f of b. So at every point, any point on the curve y equal to f of x is equal to c. At x is equal to c, this is the point c comma f of c. So according to Lagrange's mean value theorem, the tangent is parallel to the chord joining the two end points AB, as shown in the figure. At every point x is equal to c, the point c comma f of c is the tangent. There is a unique tangent is parallel to the chord joining the two end points capital A and capital B. So by Lagrange's mean value theorem, there exists at least one point C lies between open interval a comma b there. But here geometrically there exists at least one point on the curve. There exists at least one point on the curve. At least one point on the curve y equal to f of x, which is parallel to the tangent is parallel to the chord joining two end points capital A and capital B. A coordinates are small a comma f of a and B coordinates are small b comma f of b, as shown in the figure. To find the slope of the tangent, slope of the tangent will be f dash of c. The slope of the tangent is f dash of c. The slope of the chord joining two end points, two end points is the difference between the y coordinates by difference between x coordinates, that is f of b minus f of a by b minus c. This is the slope of the curve joining two end points a and b. So therefore we will equate both. The slope of the tangent will be equal to the slope of the joining two endpoints A and B. Therefore, f dash of C is equal to f of B minus f of A by B minus A. This is the view, geometrical view of Lagrange's mean value theorem. Okay, next let us go for counter example for this Lagrange's mean value theorem. For example, let us consider, let f of x is equal to log x base e is in the interval 1 comma e. To check whether this f of x function is verified Lagrange's mean value theorem or not. According to Lagrange's mean value theorem, we have f dash of c is equal to f of b minus f of a by b minus a. There exists at least one point c in open interval a comma b such that f dash of c is equal to f of b minus f of a by b minus a. So let us compare this a and b values here. Here a is equal to 1, b equal to e. So according to Lagrange's mean value theorem, f of x is a logarithmic function since f of x is continuous in closed interval 1 comma e. F of x is differentiable in open interval 1 comma e as well as f dash of x. The derivative of f of x will be f dash of x is equal to 1 by x for all x belongs to open interval 1 comma e. The differentiation of f of x is f dash of x is equal to 1 by. So substitute x is equal to c here, f dash of c is equal to 1 by c, which is equal to f of b means by Lagrange's mean value theorem. By Lagrange's mean value theorem, we have right side of the statement f of b minus f of a. That means log e base e minus log 1 base e is divided by e minus 1. This is RHS of the statement. We should equate LHS and RHS of the statement. That means that is f dash c is equal to 1 by c is equal to log e base e minus log 1 base e divided by e minus 1. So 1 by c, that is equal to 1 by c is equal to log e base e value is 1 minus log 1 value is 0 by e minus 1. So that is 1 by c is equal to 1 by e minus 1. That is c is equal to e minus 1. Let us check this c value is in between 1 comma e, the interval 1 comma e. So it is obviously it belongs to open interval 1 comma e. Therefore the given function f of x is verified by Lagrange's mean value theorem. Lagrange's mean value theorem. Mean value theorem. So let us go for geometrical special case of Lagrange's mean value theorem. Lagrange's mean value theorem applied in many engineering applications like proving of Darbach's theorem, L'Hospital rule, mean values theorem is law of mean. First motivation, we have for a smooth curve y is equal to f of x, let us find slope of the tangent. Give slope of the tangent will be f dash of c, which is equal to the slope of the joining two end points capital A and capital B. That means f dash of c is equal to f of b minus f of a by b minus a. Physical interpretation. The velocity of a particle is exactly equal to the average speed. So the Lagrange's mean values theorem, it says that f of x is real valued function is f of x is continuous in closed interval a comma b, and f of x is differentiable open interval a comma b, then there exists at least one point c lies between open interval a comma b such that f dash of c is equal to f of b minus f of a by b minus a. The alternate form of Lagrange's mean values theorem is the alternative form of Lagrange's mean value theorem is by putting b is equal to a plus h, where h is any small value, we get f of a plus h is equal to f of a plus h f dash of a plus theta h. This is another form of Lagrange's mean value theorem for some theta. For some theta, say theta is lying between 0 and 1. Theta is lies between 0 and 1. So this is another form of Lagrange's mean value theorem. Next, application of Lagrange's mean value theorem. Geometrical interpretation of Lagrange's mean value theorem be, let y equal to f of x be any curve that at every point x is equal to c, there exists a unique tangent to the curve y is equal to f of x. According to Lagrange's mean value theorem, the tangent is parallel to the chord joining to two end points A and B. So as shown in the figure, AB is curve. These are the two end points, a small a comma f of a, capital B is B f of B. So this is the tangent curve. This is the tangent to the curve y is equal to f of x. At x is equal to c, the tangent is parallel to the chord joining these two endpoints A and B. So, according to Lagrange's mean value theorem, the slope of the tangent f dash c will be equal to the slope of the line joining two endpoints, that is capital A and capital B. This is a special case of mean value theorem, that is Rolle's mean value theorem. Let f of x be any function, f of x is continuous in closed interval a comma b, f of x is differentiable in open interval a comma b, and f of a is equal to f of b, then there exists at least one point c lies between in the open interval a comma b such that f dash of c is equal to 0. Counter example for Rolle's mean value theorem is, counter example is, let us take this as f of x is equal to 2 plus x minus 1 to the power 2 by 3 in the interval 0 and 2. So, let us verify f of x is continuous. Yes, it is algebraic function, therefore it is continuous in closed interval 0 and 2. The derivative of f dash of x is equal to f dash of x is equal to x2 by 3 into 1 by x minus to the power 1 by 2. This not defined at x is equal to 1. It is not defined. It is not defined at x is equal to 1. 1 is lies between 0 and 2. Therefore, the example f of x function is not verified by Rolle's mean value theorem. So let us take another example. F of x is equal to mod x minus 1 plus mod x minus 2 on interval minus 1 comma 3. Geometrical interpretation of Rolle's mean value theorem is, let f of x be any curve f dash of c will be the slope of the tangent. So tangent to the curve is parallel to the x-axis. Therefore, according to Rolle's mean value theorem, f dash of c is equal to 0. Next, general case of mean value theorem, Lagrange's mean value theorem, that is Cauchy's mean value theorem. According to Cauchy's mean value theorem, let f of x comma g of x be two functions such that f of x, g of x are continuous in closed interval a comma b. F of x, g of x are differentiable in open interval a comma b. Then and g dash of x is not equal to 0 for some x is belongs to open interval a comma b, then there exists at least one point c in between a and b, open interval a comma b, such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. This is the general case of Lagrange's mean value theorem, alternate form of Cauchy's mean value theorem. By putting b is equal to a plus h in Cauchy's mean value theorem, we get f of a plus h minus f of a by g of a plus h minus g of a, which is equal to f dash of a plus theta h by g dash of a plus theta h for some theta. Theta is lies between 0 and 1. So, geometrical interpretation of Cauchy's mean value theorem, let consider two curves y is equal to f of t and x is equal to g of t be two curves. The slope of the tangent to the curve at t equal to c, f dash of c by g dash of c. Therefore, according to Cauchy's mean value theorem, the slope of the tangent is equal to the slope of the chord joining two end points, that is f of b minus f of a by g of b minus g of a. Therefore, f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. So, observations. Applications, many applications will be there in engineering and so many. To estimate some values of trigonometric functions like sine 36, sine 46 using mean value theorem. So Darbox's theorem, we based on mean value theorem, we prove Darbox's theorem. L'Hospital rule, if f of x tends to 0, g of x tends to 0 and f dash of x by g dash of x tends to L as the limit as x tends to c, then L'Hospital rule says that f of x by g of x tends to L as x tends to c. And one more application will be to deduce the necessary and sufficient condition of monotonic increasing or monotonic decreasing functions. Not only the above example, but many more applications can be found in different engineering applications. So this is about mean value theorem, and mean value theorem, let us go for geometrical view of mean value theorem will be, let f of x be any function, f of x be any function, f of x is continuous in closed interval a comma b. Let us take this as x axis, this as y axis as shown in the figure. F of x is any curve. So f of x is continuous in closed interval a comma b, and f of x is differentiable in open interval a comma b. So this is a point in left side, this is a point in b right side. So let us join this as these two end points, this has capital A comma f of A, this is capital B, B comma f of B. If you join these 2 points, this is the required tangent to the curve y is equal to f of x. So, if you take tangent is parallel to the chord joining these two endpoints a comma f of a and b comma f of b. The difference between y coordinates by difference between x coordinates, that is f of b minus f of a by b minus a, this is equal to the slope of the tangent f dash of c. So f dash of c is equal to f of b minus f of a by b minus a. This shows that geometrical explanation of Lagrange's mean value theorem. Thank you.